Hi everybody, we're going to talk today about concrete form construction. Concrete is heavily utilized in all forms of construction, and in residential construction, we're going to build the foundation out of concrete almost always, okay? There's two types of foundations that we might encounter, either a slab foundation or a perimeter foundation. We're going to talk more about each type of foundation, but what we're mostly going to focus on today is constructing forms to hold the concrete in place until the concrete's dry enough. Okay, and this is something that I never really knew when I was younger how they made the concrete so nice and rectangular and flat. And so what we're going to do is nail boards up, hold them up with stakes, and keep them straight, and pour concrete inside formwork. And then once that concrete's dry, we take the form boards off, and then we have this left over, okay? So we're going to talk about some different methods of doing that. So the foundation of the house is going to carry all of the loads of the house and then distribute that load back to the ground, okay? We talked before about that concept of the structural diaphragm, where we have weight on the house, with the weight of the roof itself. Maybe there's some snow on the house. Maybe there's a wind load being applied to the house. All of that transfers down to the foundation and then back down to native soil. It's only been, I would say, since the 50s that it was very common to have some kind of concrete foundation. Before, we had what's known as post and pier foundation. And we'll probably touch on this more as we progress, but the idea behind the post and pier foundation is there's not necessarily a perimeter. You just have a post every 4, 5, 6 feet. Maybe it's sitting on a pier block, depending on the age of the house. And then that pier block is maybe sitting on some native soil. Most likely not. Usually it was just sitting on the topsoil. On top of those pier blocks, like I said, there would be a post, and then on top of those posts, there would be a girder, and we'll talk more about all this. And then on top of the girder, and the girder is a big beam, like a 6x6, 6x8, something like that. On top of the girder, there would be the floor joists, and then the walls would rest on that, and then the rafters would rest on those walls. Okay, so very similar concept with this load transfer, but modern foundations are going to have concrete, either all the way around as a perimeter foundation or a big slab of concrete. Okay, the floor itself is concrete as well. All right. So when we talk about a foundation, when we talk about a modern foundation, it's going to consist of two parts. Okay, there's going to be the footings and either the slab or the stem wall, but the footings are the critical part. We don't want to just pour concrete on top of grass or on top of topsoil. We want to dig down until we hit what's called native soil, okay? Soil that hasn't been disturbed, okay? What we're trying to find in our area is clay, and more specifically, there's this yellow, kind of yellowy, orangish, brownish clay that we're trying to hit. And every time we've ever dug around here, we dig through the grass, we dig through the topsoil, and then depending on how much fill there is, we get through that nice chocolatey brown topsoil, and then we'll hit some clay that's kind of a lighter milk chocolatey brown, and then we dig through that, and then we'll hit this clay, like we call it yellow clay. It kind of looks orange yellow clay. That is good bearing soil. Okay, and there are charts that'll show different kinds of soils and what kind of weight they'll be able to hold. Okay, how many pounds per square inch they'll be able to support. Okay, if we hit that clay, we're in good shape. Okay, and during my tenure at CR, we've been buying some pretty junky lots just because there's not a whole lot of lots available right now, and we've had to dig really, really deep to get to that clay. There's usually the lots that we're buying are on fill or old cow pastures or something like that, and we've had places where the footings have been 7 feet deep. Okay. We obviously don't want to do that. And then in a lot of places, the native soil is relatively shallow. Like I've been digging at my house, and if I dig down 18 inches, I'm hitting clay. Okay. Anyway, suffice it to say, those are the footings. Okay, the footings are going to be dug down to the native soil. Okay, that's not going to get formed. We're going to form the stem wall if we're doing a crawl space foundation, and that stem wall is the part that we're going to see. Okay, it's going to be, a 6 or 8, generally 8-inch wide wall around the perimeter of the house that all the weight of the house is going to sit on, or we're doing a slab. But either way, there's going to be footings. Those footings aren't going to be formed. We're just going to let the concrete fill up against the dirt. And then when we strip the form boards off, we'll backfill up against that so that the soil slopes away from the foundation. Okay? So the foundation is, like laying out the foundation is the first part of this house build we're going to do. It is in many ways one of the most critical elements. Okay? If we start out of level, out of square, we're going to be fighting that the entire way as we build up. Okay? What we want to do is get that foundation as square as we possibly can. And remember, when we say square, we want all of the corners to be 90 degrees. And we want that foundation to be as level as we possibly can. And when we say level, we want it to be exactly horizontal. All the plane, and we want that foundation to be in one horizontal plane. Okay, perfectly flat, perfectly horizontal. Okay. If we start out wrong, like I said, we're going to be trying to compensate the entire way. Okay. As we build, we're just going to progressively get more out of square, more out of plumb, more out of level as we go, because we're using imperfect materials and we're making mistakes along the way. Okay. So if we start out as close to perfect as we can, then we have a tolerance for being out of level, being out of square. By the time we get up to the top and we're done, if everything works out, it's not a problem. Okay. So a lot of times we're building a perimeter foundation. Sometimes we're building a slab foundation. More often than not, we've done perimeter foundations, but we have in the past done a slab. We're going to talk about both methods, and it's good to know how they both work. It's good to know how to set them up because they're both commonly utilized in this area. I would say there's kind of a conception that slabs are cheaper, less expensive, and they can be, depending on what you're doing, depending on what lot you're building on. If the lot is excessively sloped, it doesn't make a whole lot of sense to pour a slab. But if the lot's relatively flat, a slab can be a good idea. The problem with the slab versus the perimeter foundation is that you can't crawl under a slab and access the plumbing or whatever else you've cast into the slab. Usually all the rough plumbing is in the slab. So if there's a problem with the sewer line, you're getting a jackhammer, okay? If you have a crawl space foundation, you can crawl underneath the house and access the floor system. So say you want to run a wire somewhere, or you want to run a new water line, or you need to go fix a plumbing leak or something like that. You can crawl under the house and access those things. Okay. So like I said, hopefully you're in tune at this point that our foundation is going to be made out of concrete. So let's talk a little bit about concrete, but we do have an entire lecture devoted to concrete. So concrete is a building material. Cement is a building material. Those two things are not necessarily interchangeable. Okay, and I want everybody to get used to saying concrete. Okay, we're going to use concrete for everything, and cement is a component of concrete. Okay, so the truck that brings concrete to the job site is called the concrete truck, not the cement truck. Okay, so when we talk about concrete, it's a blend of Portland cement, which is this certain kind of cement, aggregates, meaning sand and gravel, and water. And so when we mix those three things together, and I promise you we'll talk more about this, but when we mix those three things together, a chemical reaction begins. As the water evaporates, the concrete hardens. Okay? So what we're going to talk about today is how we are going to construct forms. We're going to nail boards onto stakes and build a box that's going to hold the concrete in place while it cures. Okay? So one thing about concrete is it's really good at resisting compressive loads. We can put a lot of weight on top of concrete, and as long as it's supported underneath, as long as it's sitting on some native soil, it won't crack or break or crush. Okay? It has really high compressive strength. This is a picture right here of compressive strength versus tensile strength. Okay? So these are two concepts that we should be pretty familiar with because these come up a lot in construction. And it's important to know how loads work on a house, how loads react with our building materials. So if we talk about a compressive loads are trying to crush something. Okay? I'm standing on an aluminum can and I'm applying a compressive load to that aluminum can. Okay? And it's probably going to crush depending on how heavy I am. Okay? When we talk about a tensile load is trying to pull something apart. Okay? So I've got a piece of taffy and I'm stretching it between my hands, and eventually it's going to get thinner and thinner and thinner, and eventually it's going to break. Okay? That's a tensile load. So this picture right here, it's kind of confusing sometimes, but this is very obviously a compressive load. We've got a post or a pillar in the ground, and we're putting weight on it, and we're not going to be able to crush it. Okay? When we lay the concrete in the opposite direction and it's not fully supported, and we apply a load to it, it wants to deflect in the middle and push apart. And concrete will crack under those circumstances. If you're ever trying to break an old sidewalk apart or break a slab apart or something like that, if it is lying flat on the gravel, and you can bang the heck out of it with a sledgehammer or a jackhammer, and it's going to be really hard work. But if you can get under a section of that concrete and lift it up and put a rock or another piece of concrete or something underneath it so that there's a space between that sidewalk or slab, you can put very little effort into hitting it with a sledgehammer and it'll break into pieces, break into manageable pieces. Okay? Unless that concrete has rebar in it. Okay? Rebar is short for reinforcing bar. Okay? And we're gonna talk more about that in a minute. But when you add steel, steel contributes an incredible amount of tensile strength to the concrete. Okay? So rebar or welded wire mesh, WWM, are the two options for adding tensile strength to concrete. Rebar, if you don't know what it is, it's a bar 20 feet long in varying thicknesses with kind of a spiral around it. And you usually, if you're doing a slab, you'll make like a tic-tac-toe style grid pattern with it. If we're just doing like a perimeter foundation, we'll just hang pieces of rebar parallel with the forms. Okay. Welded wire mesh, we would only use in a slab or flat work, and it's like a 4 or 5 foot wide by 8 or 10 foot tall sheet of 1/4 inch rod, and it's a bunch of little like 4-inch squares. Okay, and what you do is you just throw that in the wet concrete, make sure that you pick it up as you're moving around, as you're pouring concrete, so that the concrete gets all the way around that wire mesh. You don't want it just sitting on the bottom. Okay, and that's going to add tensile strength. Okay. One thing I want to be really clear about, and people have a misconception about this, is concrete is going to crack. Okay. The joke with concrete is I can make two guarantees. It's going to get hard and it's going to crack. Okay. So people have this idea that if they just add more and more steel, if they add, double the amount of rebar that's being called for, then their concrete won't crack. Okay, we'll talk more about managing cracks in concrete later on, but just think about when we add steel, the tensile strength that's added keeps that concrete together when it cracks. Okay, there's a certain amount of maybe resisting cracks, but there's going to be hairline cracks all over any piece of concrete that we pour. And that steel is going to prevent those cracks from separating. It's going to prevent those pieces of concrete from separating.